Hello, welcome to this video. So this problem, will be about compound interest. So that will be about the application of percentages, and more importantly, so that will be about sequence and series. So Peter borrows a loan of $200,000 from bank. At an interest rate of 6% per annum, compounded monthly. So it's about the loan repaying scheme. So and then that's very important. So for each successive month, that means, let's say, for the following months after the day when the loan is taken. So of course, so the bank, or the financial institutions, they need to have their profits. So of course, after the day when the loan is taken, of course, the loan interest, will be calculated. And then a monthly installment of $X is immediately paid to the bank until the loan is fully paid. So here, for the loan interest, so the loan interest, for the first month. So the principal, will be 200,000. And then after 1 month, so that will be times 1 plus 6% over 12. The 6%, will be the interest rate per year. Then compound monthly, so that means 6% for a year. Then 1 month, will be 6% for 12. So that will be the monthly interest rate. So that will be the amount of money Peter owed to the bank after 1 month. And then minus 200,000. And then using the calculator, so that will be $1,000. That means, the bank after 1 month, the profit, will be 1,000. $1,000. A2. So expressed in terms of X, the amount of Peter still owes the bank after paying the first installment. That will be the required amount. So the required amount, so again, for the first month, right? So 200,000 times 1 plus 6% over 12. So that will be the amount of money Peter owes to the bank after 1 month. Before the monthly installment of $X is paid to the bank. So after paying the first installment, so $X. And then we try to simplify it. So that would be $201,000. And then minus X. It's that simple. So that will be A2 or A3. So this part, will be quite difficult. So that's why here I would like to explain in details. To be more systematic, so we try to let FM be the amount of money that Peter still owe the bank. After paying the nth installment. So in particular here, so this is a sequence, because of from A2, from A2. So we got F1 already. But here, I'll recommend you, to write down, not write down the answer, but try to write down the expression. Okay, from the expression we can find the pattern. Okay, so F1 okay would be 200,000 and then times 1.005. Okay, so 1.05 will be originated from 1 plus 6% over 12. Okay, so decimal form, so 1.005 and then minus 6. Okay, so this can be found in part A2. Okay, and then F2. Okay, so we'll be using the amount of money that Peter still owed the bank after paying the first installment. Okay, we try to copy this. Okay, so and then after another month, so that's why times 1.005 again. Okay, so here I need to write that down. So 1 plus 6% over 12 equals to 1.005. Okay, so and then that will be the amount still owe the bank after paying before paying the second installment. Okay, at the end of the second month. So and then after paying the installment, the second installment, so minus another x. Okay, so and then the 1.05 okay multiply inside the bracket, so that's why 200,000 times 1.05 square. And then there are two x terms here, and then we try to organize a bit, so that's why minus x times 1.05 plus 1. Okay, so and then F3, so that would be the amount of money still owe the bank after paying the second installment. Copy again, and then another month, another 1 month time, so that's why times 1.05, and then after paying the third installment, so minus x again, and then the 1.05 in multiply inside the square bracket using the distributive property. So that's why this time 1.05 to the power of 3 and then minus x, okay, because we have 3 x terms here, so 1.05 square plus 1.005 and then plus 1. And this is the expressions, okay, for F1, F2, and F3s. Okay, so and then we need Fn. We need Fn. Okay, so that's why here, so dot maybe, okay, so we need Fn. So here, okay, we may need to look at the pattern. So what pattern do we get? So here, if this is F1, so this is to the power of 1. F2, so square. F3, so this is cube. So that's why Fn, so easy to get. The first term, so 200,000 times 1.05 to the power of n. Not difficult to get. Okay, and here, so F2, so here 1 plus 1.05 and then 3, 1 plus 1.05 and then to the square. Okay, so and then we have 3 terms for F3, we have 2 x terms for F2, and then we have 1 x term for F1. So that's why, okay, for Fn, okay, so we have 1.005 to the power of n minus 1. Okay, and then 1.05 n minus 2. And then plus blah 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 plus dot 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 plus 1.05 and then plus 1. Okay, so we keep the first term. Particularly here, I think all of us, okay, should be looking at the final answer, the answer we are going to show, okay, for this part. Okay, so now you can see x, and then inside the bracket, that will be a geometric series here. Now here, okay, if we try to take 1 as the first term, okay, so you can see every term multiplied by 1.005. Okay, So that's why here, okay, the common ratio, okay, will be 1.005. Okay, and then for the terms here, okay, so you can see for F1 we have 1x term, for F2 we have 2x terms, for F3 we have 3x terms, so that's why for Fn we have nx terms here. Okay, so and then for the denominator 1.05 minus 1. Okay, so and then we try to use the calculator 1 over 1.05 minus 1. Using the calculator we'll get 200. Okay, so that's why at the end we'll get the expression as we want. And then this part is done. These are the most difficult parts. Okay, so and then for B, so that will be the application. Okay, using A3. Okay, so here particularly we need to look at this fraction, prove that, okay, in the last part. So suppose that Peter's monthly installment is $1,800. So actually this is X now. So X equals 1,800. So find the number of months, okay, for Peter to fully repay the loan. Okay, so that means, okay, here we try to set, so that B1, we try to set this X now is 1,800. Okay, so and then 1.05 to the power of n minus 1. Okay, we try to set it to be less than or equal to 0. Okay, why less than or equal to 0? To be so to fully repay the loan. Okay, that means, okay, the amount of money after paying the nth installment should be equal to 0, because, okay, you will try to repay all the loan, fully repay all the loan. Okay, that means the outstanding balance, okay, after paying the nth installment, we're going to find the number of months. Okay, that means we try to find the n. Okay, so that's why we try to set it to be 0. And then why less than? Okay, so actually we try to make use of inequality, so that we can find out the least value of n. Okay, of course not bigger than, because, okay, if bigger than, that means the debt, okay, the loan is still not fully repaid. Okay, so and then here we try to organize a bit. Okay, so maybe we try to multiply everything. So 200 times 1,800. Okay, so that will be 3,600. Oh yeah, so for 360,000. Oh yeah, and then times 1.005 to the power of n, and then plus this. Okay, and then we can have the two cross terms here. Okay, the first two terms, okay, both contains 1.005 to the power of n. So that's why here negative 160,000 times 1.05 to the power of n less than or equal to negative 360,000, and dividing both sides by negative 160,000. Okay, we get 1.005 to the power of n less than or equal to 2.25. Okay, so because, okay, we want to solve the n, okay, and then n, okay, will be the exponent, so that's why, of course, okay, we will make 1.05 to the power of n as the subject, and then, okay, we try to take log on both sides of the inequality. Okay, so and then using the log run property, the N can pull down. And then divide both sides by log of 1.05. We will get N will be bigger than 162.5911713. So that means, okay, the list value of N, okay, will be 163. So that's why, okay, so Peter needs 163 months to fully repay the loans. Okay, that's part B1. And then for B2, okay, so Peter wants to fully repay the loan with a smaller monthly installment. He suggests or requests, okay, to pay a monthly installment of $900 instead of 1,800. However, the bank refuses his request. Why? Now here, okay, so you can see $900, and here, okay, so the reason is very simple. Okay, so if you try to refer back, okay, to the answer, okay, in part A1, okay, so the answer for part A1, okay, will be just $1,000. Okay, but however, the loan interest, okay, for the first month is $1,000. But if the fixed monthly installment, okay, $900, is already less than the loan interest for the first month, that means, okay, the monthly installment is even not enough for the loan interest for the first month. If you try to compare, okay, you try to compare. So that's why, okay, the bank must refuse his request. Okay, so that's why here, okay, the reason is very simple. Okay, so you may just argue, oh, because $900 are less than $1,000. So that's why, okay, Peter, okay, cannot repay the loan. And so the bank would refuses, okay, the bank refuses his request. Okay, and then this part is done. Okay, thank you for watching.